are in a chapter 5, heat. Okay, and in the last class what we have learned about two very interesting topics, that is regulation and anomalous behavior of water. Okay, so in regulation we have seen this activity of ice and weight. Okay, so from this what we have learned, that the phenomenon of regulation. So what is regulation? The phenomenon in which the ice converts to liquid due to the applied pressure and then reconverts to ice once the pressure is removed. So this is called as what? This is called as regulation. Okay, so the melting point of ice becomes lower than 0 degree Celsius due to pressure. Okay, melting point of ice will become lower than 0 degree Celsius due to pressure. Okay, so this means what? This means that at 0 degree Celsius the ice gets converted into water. Okay, below that it doesn't get converted into water, but at 0 degree Celsius what happens? The ice gets converted into water. Okay, yes. So students, this is the activity which we have seen in our last class. So here what happens, as soon as the pressure is removed, the melting point is restored to 0 degree Celsius and water gets converted into what? It gets converted into ice again. Okay, so this is a regulation activity which we have learned in our last class. Then the very interesting topic, that is anomalous behavior of water. Okay, here we have seen the Hobbes apparatus and this graph, the graph between the volume and the temperature of water. Okay, so here what this graph shows, so this graph shows about the behavior of water between what? It's between its temperature from 0 degree Celsius to 4 degree Celsius, and this is called as which behavior of water? This is called as anomalous behavior of water. Okay, so at 4 degree Celsius you can see over here in this diagram what happens. At 0 degree Celsius the volume of water is minimum. Okay, here in this graph, the graph shows the volume of water which is very minimum. Over here you can see, yes, so it means what? It means that the density of water is maximum at 0 degree Celsius. Okay, and its volume is minimum at 4 degree Celsius, and its density is maximum at 4 degree Celsius, which means what? As the formula says, density is equal to mass upon volume. तो जब density जो है वो ज़्यादा हो जाती है तब volume कम हो जाता है. So like that. Here then this activity or this anomalous behavior of water we have learned with the help of which apparatus? Hobbes apparatus. Okay, so students, this is the this is a concept which we have learned very conceptually in our last class. Okay, so then here is one graph which shows the time temperature graph. The temperature is plotted on y-axis. Here you can see the temperature is plotted on y-axis, yes, and the time in minute on the x-axis. Here you can see the time which is shown in minutes on x-axis. Okay, so here what happens, the graph shows that initially both the temperature T1, this is T1 and this is T2. So they are what? They are identical to each other, yes. But as the time passes, what happened? The temperature T1 of water in the lower part of the cylinder decreases fast. Okay, so it gets decreases very fast. And T2 of water in upper part of cylinder, what happens? It gets decreases slowly. Okay. Yes, so once the temperature T1 of the lower part reaches to 4 degree Celsius, okay, so it remains almost stable at that temperature. And at the 4 degree Celsius, here you can see the point which shows maximum density. Okay, the 4 degree Celsius, the point of intersection, this is called as the point of intersection. Okay, and T2 shows T2 decreases slowly at 4 degree Celsius. पहले कौन डिक्रीज हो जाता है? पहले T1 जो है वो जल्दी से डिक्रीज हो जाता है. ओके, एंड T2 जो है उसको टाइम लगता है. इट विल टेक टाइम टू डिक्रीजेस slowly. Okay, So students, these are the concepts which we have learned in our last class. Please go and watch that video. Okay, so now today again another interesting topic which we are going to study, that is dew point and humidity. Okay, so here what happens, it is all about weather, it is all about climate, it is all about droplets. So it is very interesting, you will enjoy this topic. Yes, so here student, about 71% surface of the earth is covered with what? It is covered with water. Okay, so due to constant evaporation of water, what happens? Water vapor is always present in the atmosphere. Okay, जब water का evaporation होता है तो क्या होता है? Water vapor form हो जाते हैं in the atmosphere. Yes, you all know that. Okay, then the amount of water vapor in the atmosphere helps us to understand the state of daily weather. ओके जितने जैसे भी वाटर वेपर रहेंगे इन द एटमॉस्फेयर, सो फ्रॉम दैट विल गेट टू नो द स्टेट ऑफ डेली weather. Okay, like this, today we have a cloudy weather, rainy weather, like that. Okay, so we'll get to know about the weather is cloudy or it is clear, like that. Okay, so the presence of water vapor in the air makes it moist. ओके सो जब वाटर वेपर रहता है तब वेदर कैसा रहता है? मॉइस्ट रहता है. सो द मॉइस्चर इन द एटमॉस्फियर, ओके, द मॉइस्चर इन द एटमॉस्फियर इज कॉल्ड एज ह्यूमिडिटी. जितना भी जैसे भी एटमॉस्फियर में मॉइस्चर प्रेजेंट रहता है उसको क्या बोलते हैं? इट इज कॉल्ड एज ह्यूमिडिटी. ओके, यस, देन for a given volume of air at specific temperature, there is a limit on how much water vapor the air can contain. Okay, so now let's see, there is one limit, that how much water vapor the air can contain. If the amount exceeds this limit, then what happens? The excess of vapor gets converted into water droplet. जो भी अमाउंट है वो अमाउंट से ज़्यादा हो गए तो क्या होता है? एक्सेस ऑफ वेपर जो होते हैं वो गेट्स कन्वर्टेड इनटू व्हाट? वाटर ड्रॉपलेट्स. Okay, when the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. Okay, so here the saturation takes place. Okay, so the amount of vapor needed to saturate the air depend on what? It is depend on temperature of the air. एयर में कितना टेम्परेचर है तो उसके ऊपर ये सैचुरेशन डिपेंड करता है. ओके, yes, so if air temperature is low, it will need less vapor to saturate the air. For example, if the temperature of air is 40 degrees Celsius, then it can contain 49 grams of water vapor per kilogram of dry air without condensation. And if the temperature of air is 20 degrees Celsius, that means what? It is lower than this temperature, then it can contain only 14.7 grams of water vapor per kilogram of dry air without condensing. So here जितना temperature lower रहेगा उतना ही अच्छा है. So the temperature should be lower. Okay, if the vapor contained in air is less than the maximum limit, then the air is said to be unsaturated. Okay, yes, so suppose unsaturated air at a certain temperature is taken and its temperature is decreased, a temperature is reached at which the air becomes saturated with vapor, then this is called a dew point temperature. तो टेम्परेचर जो है जो एक लेवल पे रीच हो जाता है, एट विच द एयर जो है वो सैचुरेट हो जाती है विथ वाटर, सो दिस इज कॉल्ड एज व्हाट? ड्यू पॉइंट टेम्परेचर. ओके, द vapor contained in air is measured using a physical quantity called absolute humidity. The mass of vapor present in a unit volume of air is called absolute humidity. So the mass of vapor which is present in a unit volume of air, so it is called as what? Absolute humidity. Generally, absolute humidity is measured in terms of kg per meter cube. Students ध्यान में रखना कि एब्सोल्यूट ह्यूमिडिटी जो है वो किस में मेजर हो जाती है, इट इज मेजर्ड इन kg per meter cube. Okay, yes, so the ratio of the feeling of humid or dry nature of air not only depends on the amount of vapor in the air, but also it is depend upon what? But also it is depend on how close the amount is for making the air saturated with vapor. It means what? It is depends upon the temperature of air. As I have told earlier that it is depend upon what? Temperature of air. Okay. The ratio of actual mass of vapor contained in the air for a given volume and the temperature to that required to make the air saturated with vapor at that temperature is called the relative humidity. So the percentage relative humidity is equal to what? Actual mass of water vapor contained in the air in a given volume divided by mass of water needed to make the air saturated in that volume into 100. So this is a formula which is very important regarding to your numericals. Okay, so please remember this formula. Yes. Now the relative humidity at the dew point is 100%. If the relative humidity is more than 60%, then what happened? We feel that the air is humid. Okay, the air is humid. Air is not clear. Okay. Yes, air is humid. If the relative humidity is less than 60%, then we feel that air is dry. But यहाँ पे देखो, जब relative humidity ज़्यादा होती है 60% से, then we feel that air is humid. But when the relative humidity is less than 60%, we feel that the air is dry. Okay. Yes. So after that, students, I hope till now you all have seen this concept. So what is the reason behind this concept? Now we are going to see. Okay, so during winter season, you may have observed a white trail at the back of lying plane in the clear sky. Okay, so this is the plane and this is a white trail which we have observed during the winter season. Okay, so as the plane flies, what happened? The vapor released by the aeroplane engine condensed and it formed cloud. So this will form a cloud. If the surrounding air is having more relative humidity, then it takes a long time for a white trail formed by condensation of vapor to disappear. जब भी ऐसी वाइट टेल हमको दिखाई देती है, तब कभी कभी तो बहुत टाइम लगता है to disappear this white trail. So because of what? The surrounding air is having more relative humidity. Okay, it having more relative humidity, so it takes a long time for the white trail to formed by condensation of water to disappear. Okay, and if the relative humidity of the surrounding air is less, then what happened? Either the size of the white trail may be small or it may not even get formed. Okay, जब relative humidity कम होती है तब ये जो ट्रेल है वो फॉर्म ही नहीं होती और उसकी साइज जो है वो वेरी स्मॉल हो जाती है. ओके, इतनी बड़ी साइज हो जाती है विच मीन्स वॉट? उसकी ह्यूमिडिटी, रिलेटिव ह्यूमिडिटी इज वेरी हाई. Okay, yes. Now students, there is one activity which is given in your page number 67 textbook. It is like try this. Okay, so for this what it says that take a bottle of cold water out of a refrigerator and keep it outside for a while and observe the outer surface of the water. Okay, so water droplet gets formed at the outer surface of this bottle. Yes, drops. Then the second activity, drops of water can be observed on the outer surface of bottle over here. In the same way, what happened in the second activity, if we observe the leaves of plants or grass, okay, or the window glass of a vehicle in the early morning, we see water droplets collected on its surface. Yes, so here these are the two observations. From this we sense that the presence of water vapor in the atmosphere. तो वाटर वेपर है एटमॉस्फेयर में, इसीलिए ये सब हो रहा है. When air cools due to decrease in temperature, it becomes saturated with water vapor. जब भी एयर जो है वो ठंडी रहती है, due to decrease in temperature, it becomes what? Saturated with water vapor. Okay, and as a result what happened, the excess water vapor gets converted into tiny droplets. Okay, these are the tiny droplets. So excess of water vapor gets converted into what? Tiny droplets. And the dew point temperature is decided by the amount of vapor in the air. तो dew point of temperature कैसे decide होता है? By the amount of vapor in the air. Okay, so students, unit of heat. What is the unit of heat? The unit of heat are joule in SI units and calorie in CGS unit. Okay, the amount of heat necessary to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 degree Celsius to 15.5 degree Celsius is called as 1 calorie heat. Okay, it is called as 1 calorie heat. But what do you mean by 1 kilocalorie heat? The amount of heat necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degree Celsius to 15.5 degree Celsius is called as 1 kilocalorie heat. Okay, so here 1 gram is taken, here 1 kg is taken. That's why 1 calorie and 1 kilocalorie. So that from this it is clear that 1 kilocalorie is equal to what? 1000 calorie. Okay, 1 kilocalorie is equal to 1000 calorie. Okay, so here is a one question that what we are why we are going to take, why we take this kind of temperature, that is 14.5 degree Celsius to 15.5 degree Celsius. तो यही क्यों लिया? 12 degree Celsius to 13 degree Celsius क्यों नहीं लिया? Or like that. So here is a answer which is given in your page number 67. Always remember. So if we heat 1 kg of water by 1 degree Celsius in different temperature range, then 14.5 degree Celsius to 15.5 degree Celsius, the amount of heat required will be slightly different. तो हमने ये नहीं लिया और कुछ और लिया तो क्या होगा? जो आंसर हमको मिलेगा वो कुछ डिफरेंट रहेगा. ओके, देयरफॉर द एसेंशियल it is essential to define a specific temperature range while defining the unit of heat. Okay, so अब अगर यही लिया, अगर यही टेम्परेचर हम लेते हैं तो क्या मिलता है हमको? आंसर जो है वो एक्यूरेट मिलता है. we will get an accurate answer. So what answer we'll get? That is calorie and joule, okay, are related by the following relation. 1 calorie is equal to 4.18 joule. Okay, so 1 calorie जो है it is equal to what? 4.18 joule. Yes. So students, this is all about your today's topic. So today we have learned about humidity and dew point. Go through the video and complete your assignment. Thank you students.